the importance of being complete. Hot topics.
When are you gonna tell me to stop talking? So in 17 minutes? Okay, I'm just making sure, because my role in this talk is, and I'm gonna put my own timer on, just because I trust Daniela, but I also just doing this way. I am what you can call the hype woman for what you guys are gonna do in the next portion of this, which is gonna be get together and discuss all the ways that we're gonna be as complete as possible, okay? So consider me the hype. I'm hyping. You guys are gonna get excited and then you're gonna talk to each other and we're gonna solve all the things. I like it, wherever that energy is coming from. Let's get that in the front, because this seems a little quiet up here. Will, you're looking at stuff like, let's go, attention here. So, hot topics and discussion motivator, that is the title. I'm gonna just start with a pretty video. This is a video that starts with the 100 parsec sample of stars, color-coded by temperature, really color-coded by their guide G minus RP color. And then it's gonna drop down and sort of fade away as we're gonna pull away from that. It's the sun at the center there. And then all that's left is the 20 parsec sample, the 20 parsec sample. Basically the spitting distance away from the solar neighborhood. I don't know why we like even numbers so much, why 20 parsecs feels like the right number, why not 17.5 parsecs, why not 6.4 parsecs, whatever, we're in 20 parsecs here. And as we're pulling away, you're seeing the distribution, and you might be noticing quite a number of the reddish type stars. A lot of the discussion has been on how many of the low mass stars are in the solar vicinity. Now, question to the room, how many people think there are discoveries to be made in the 20 parsec volume? Okay, I didn't see every hand up, and every hand should be up. All right. How about within 10 parsecs of the sun? What? Something we don't know about, we don't know about yet. All right, okay, we'll just keep going. How about 5 parsecs? Less the room. What about 2.2 parsecs? How many people don't think there's something within 2.2 parsecs to be discovered? AKA closer than Proxima Centauri. Is there an object between us, the sun, and Proxima Centauri that we haven't found yet? Who is? It's a cloud. Well, out of the solar system. Oh my God. I am failing. This is a failure. Is there another object? Is there an A star between us and Proxima Centauri? Yeah. Awesome. Now we're getting on the same page. Is there a K dwarf? Great. Is there an M dwarf? Is there a T dwarf? You're getting quieter. Is there a Y dwarf? I was trying to do. Just as a reminder, this is a little video that we made actually for the release of the Backyard World Planet 9 project, Trent, that shows the top 4 closest systems to the sun. And I say systems, of course, because we all know that nothing's really singular at some level. And if you ever ask the general public, what's the closest star, right, they can usually say, they usually say, no, it's the sun. No. I'm the hype person, but I feel like I'm not doing my job. The closest star is the sun. Then they may say Alpha Centauri, right? They miss out on Proxima Centauri. But then get them to do the next one, and you get a little blank stare. And then the third and the fourth one, welcome to the awesome land of these 2 objects. Well, Lumen 16, WISE 1049 A and B, and WISE 0855, right? Published in 2013 and 2014. redoing our local solar neighborhood. How many people couldn't believe it when WISE 1049 was discovered? That they were like, why didn't we find that in 19 whatever year?
This one got the Hammond way to the 80s.
Yeah, but why did us thinking what that thing is? What's wrong with us that we missed it? We could have got it in so many images. It was in so many images. Why did we miss it? Why? I ask myself this on almost a daily basis. Why? Why? Why did it come down and why is it published in a single author paper? Kevin, just Kevin. Kevin's not at the meeting, right? Oh, Chris has an answer. Let's go. This is interactive.
Hemispherical chauvinism.
Yes.
If that object was in the northern hemisphere, it would have been found.
Snaps for Chris. Yes. All right. All right. Now we're on to stuff. Problems with hemispheres, huh? Anybody else want to join in this talk? Because it feels like this is what we're doing. All right. Why is only 55? Why didn't we find that one? Because it's freaking faint. But look at it in this WISE view image that Dan Castleton right there, citizen scientist, helped us create this thing. This is a whopper of an object now. In hindsight, this feels like, man, oh man, look at this thing. It's awesome, right? Okay. I'm totally going to run out of time, but don't worry. I'm at 6 minutes. We're going to make it. All right. So with these two objects, and we've already identified something very interesting. Number one, maybe we missed WISE 1049 because of a hemisphere bias. Southern hemisphere got overlooked a little bit more. Maybe we missed WISE 0855 because it's stinking faint. So what other objects are out there? There's a lot of them out there. And so Backyard World, you heard Tom Bickle, awesomeness from Tom Bickle in the audience, citizen scientist, explain the work that we've been trying with the Backyard World Citizen Science Project. Because frankly, when I saw those two objects, WISE 1049 and WISE 0855 come out, I freaked out of like, I am sure there's a brown dwarf closer than Proxima Centauri. I am positive of it. I would bet so much money that there is. Like $7 billion. Doesn't matter. I can say a number because who cares? Because it's not, even if it's not, I mean, maybe we'll all be dead by the time it's found. And then I still don't lose. These are all discoveries that were made by citizen scientists as we started to go to town searching the solar vicinity in the neighborhood. The problem is we may be instrument limited at this point as well. So just to go over a couple of things, remember the completeness at the bottom of the main sequence. You know, historically, these amazing surveys, Dennis, TUMAS, Spitzer, WISE, PanSTARRS, name them. It's not that they're not still making some awesome discoveries, because they are, but we're kind of tapped out, right? So how are we going to find, what are we going to do? What's the motivator here? This is what you guys need to think about for this next session, because we should come up with something. Some of us are too old, some of us are very young, but some of us. Some of us are young in the room. Some of us are not as young. But the youngers, think of the mission that will locate these objects and get us more complete in the near future. So maybe it's some of these future missions. We've heard some, I put Web up there because I don't think we've maxed out on Web at all. We are not even scratching the surface of what Web's going to do. But SphereX is coming. LSST is coming. Euclid's here, I guess. Roman, all of these. So where are we going to get the rest of these cold objects? One thing I want the room to think about, and maybe this will come in when everybody goes into the discussion, is, okay, what are we going to do when we lose Webb? If we're going to follow up on finding an object closer than Proxima Centauri. What's the plan, people? Anybody have a plan? In the next session, you should come up with a plan. Come up with a spectroscopic plan for how we're going to follow. We can't even follow up all the candidates that we have now. Webb has to give us more time, so if you're on the TAC, please. Because 1 to 5 of you will be in the TAC. And you could give time to get some spectroscopy of some of these cold objects, because we're desperate at the cold end of things. But what comes after Webb for spectra for following up? And then How many people know about infrared Gaia? Raise your hand.
White paper.
White paper where? You're staring at the ceiling, Jose. Oh, okay, yes. I don't know what you were doing, but good. Gaia in the near eye, but it's not set yet, right? What are the filters? What filters are they're gonna look at? That's the kind of thing that we can help design right now, so we can maximize on the opportunities for possibly an astrometry mission of the future. All right, now a couple of other things that I think are really interesting for where maybe some of these objects, why we're not totally complete, why completion is not at our fingertips yet, and why this is hard. What about, we identified hemisphere problems, northern and southern hemispheres. Thank you, Chris, who, by the way, lives in the southern hemisphere. Do you guys realize that? Maybe you are biased against the southern, you are biased against Chris. He lives in the southern hemisphere. How many of you live in the southern hemisphere? I don't see that many hands up, Babs, with beautiful telescopes, but we should not ignore the southern hemisphere. I don't know why I did that, but okay. All right. Are there other parts of the sky? The galactic plane, the disaster. Tom showed the hell versus easy stuff that we tried with Backyard Worlds, what was called Plane Party, to try and do the galactic plane. Are there things hiding in the galactic plane? When Gaia came out, I was convinced we were going to find so many good things in the galactic plane. But that, on the left-hand side, is an ATOF projection of the Gaia 20 parsec sample with DR2. Notice that's the Gaia 20 parsec sample. All those dots are objects that Gaia detected. Do you see anything wrong there? Do you see anything wrong there? Is the Milky Way within 20 parsecs? Not the last time I checked. Are the LMC and SMC are actually not quite in there as visible, but no, problematic area. But we actually found right away this L7 that was just hiding in the galactic plane, and Gaia just found it right there. Davy had a really nice plot in the 2024 paper that was attempting to show the distribution on the sky of the L's and the T's and the Y's. And it doesn't look so bad, but those Y dwarfs, we don't have a great sampling across the sky anyway. So are we missing stuff in the galactic plane? Maybe that is where that hidden brown dwarf is. Maybe not. Still betting what did I say, 7 billion? I'm gonna up it. $75 billion says it's in the galactic plane. Prove me wrong. All right. Other objects that might be hiding. This is another little video that I made. I actually made this video when Kareem El-Badri, who I don't think he's at this meeting, wrote an amazing paper with all of these new companions found in Gaia. So everything that you're seeing moving it'll look like there's double moving in front of you. It should, because everything that's moving is a co-moving system. Lots and lots and lots of new co-moving systems that were found in Gaia. Widely separated though. So depending on what volume you're at, you're going to have problems with finding the exact ratio, mass ratio and separation ratio. So how are you going to get complete for all of your companions? And how are you going to find all the coldest ones? Because I'm a little bit more focused on the coldest ones in this talk. We've certainly been finding more of them with Backyard Worlds. Backyard Worlds has been very successful at just eyeballing things and trying to combine surveys. So we've done a lot of combination surveys of Gaia, the amazing Gaia, which seems like it's getting pretty complete on our higher mass objects, and then say Ys or cat-wise, and finding the orange dots jumping around with the higher mass stars. But are we missing some? Is there any way to know that we are going to ever be complete for companions? Does anybody want to guess? I'll give you the answer. Do you want to guess if we're going to be complete with companions? How many people say yes? Let's say 70 billion years. Sweet. All right. I'm going to go right to the next major problem we have that's missing, and that is young objects. How many people think we're complete on all of the young moving groups or clusters that are within, let's say, 100 parsecs? How many people think we found them all? What about 50 parsecs? What about 2 parsecs? Trick question. Yeah, this is just a video. If you saw Jonathan Gagne's talk, you know, like this is getting completely obliterated with Gaia with so many associations. And I just wanted to bring up this one, which Jonathan also brought up this morning. This is from a paper that Jonathan led in 2023, and it was on a new association that is called Oceanus. It's a 500 to 600 million year old association, the home of Lumen 16. Yeah. Oh man, was that you, Trent? You got that wrong? No. Lumen 16 AB or Y1049 AB, the system discovered in 2013 that became the third closest system to the sun. We didn't even know about it. We were so motivated by that object that during what we call Gaia DR3 Hack Day, something that happens in New York City where we all get together and hack the data sets when it's released, we decided to look for some new associations. And immediately what popped out was this clustering of objects. And then we, of course, always check the brown dwarfs because our goal at some level in the low mass side of things is to find out where all these brown dwarfs might belong to. And out pops Oceanus, this 500 million year old association that's sweeping over the sun. And and it makes a lot of sense for figuring out the components of the Lumen 16 or the Y1049 system. We are definitely missing young associations. There are definitely more of them out there. And then last, these are all just stuff for you guys to think about. This is what I was told to do. I'm just saying. This is what I was given. Give you the hot topics. Low metallicity objects. Have we found all the low metallicity objects near the sun? Have we even come close? What did you say? What did you say? Why are you guys asking follow-up questions? Just answer. Fine, within 20 parsecs. Within 25 parsecs. No, we don't know anything. I think that's my point in this hot topics. I don't think we know all that much. And this object, which I'll make bounce for a second, and don't worry, Danielle, this is my last one. Why is 1534 there, which is lovingly called the accident, because it was accidentally discovered by this man, Dan Castleton, and he lovingly called it the accident, and it boggled many of us on the Backyard Worlds team. Davey led this paper upon data that Fede Morocco got from Hubble. We got the parallax for it. Do you see where it lives on this color magnitude diagram? Do you see that? It looks like I'm gonna make it blink again so you guys can get excited again. Do you see that? See how weird that is in color magnitude diagrams for low mass objects? It's bizarre. Davey put the paper out, and guess who retweeted the press release? No, but yes. No. Guess who retweeted it? No. Any other guesses? He's evil. He's evil. Guess who got so excited about this object? No. No. Come on. No one's going to guess the evil empire spaceman himself. Elon Musk. Elon Musk tweeted the press release, and then all of a sudden, all these extra press people wanted to talk to Davey about this object. I'm pretty sure that Avi Loeb is going to write a paper about it being an alien spacecraft. We're about to get a JWST spectrum of it. If Aaron Meister is in the room, is Aaron here? What? Who? Oh, no. I'm in so much trouble. Who cares? Come on, me, bro. Is Aaron in the room? Aaron's not in the room. All right. Well, Aaron has a JWST space. That object will be observed any really second now, maybe in the month. And we'll figure out what's going on with it. But the way that it sits out there, where are the other ones like it? It's cold. It's very close to us. We are completely missing objects like this. I don't know how we have any hope of finding them. All right. Well, so leaving you with these hot topics and discussion motivators for this next session where everybody's going to get around and solve all of this. Number one, how are we going to follow up on these cold brown dwarf objects? Come up with a mission. Let's do this together. Wouldn't it be fun if we proposed? Davey had a good idea. Can I say what the good idea was or no? Yes! Take Gaia and push it out to the orbit of Mars, creating a bigger baseline. Hello. This is a brainstorm, people. That's what's coming next, brainstorm. They're not gonna push it to Mars, are they? Okay, well, then it has to keep getting data. Yeah, we can't do that to have it die, Ricky. We'll come up with an idea. I think we should just maybe we build a 700-meter mid-infrared perfect astrometry mission. That would be awesome. ATN, what do you got? ATN is an ideas man.
Yeah, I have
We're at the
a
end.
very provocative question. Maybe that thing at like 0.4 parsec is in WISE. It's there. We're just not looking properly. Except just do the math, like thought experiment. You think that the brown dwarf at 2 parsec, it's moving 9.5 seconds a year. Then put it at, let's say, 5 times closer, it's moving nearly an arc minute a year. Would it be missed?
Would it be missed?
So it's the only, so you cannot like literally train because there's just one object
Yeah.
like that. Are we looking? So it's very provocative. You should get it. Someone wants to put a fake one in the data? It's just
I'm with ATN.
a few arc minutes a year, let's say, if you really, really want to be sure.
Yeah. I feel like we've now moved into let's come up with the crazy ideas. Let's go with the crazy ideas. So Daniela, you take it over.
Thank Jackie for the awesome talk. I'm actually gonna leave the hot topics here. So now your job. Please find out which group